Hello student, welcome to all of you in the next physics lecture. Now we have to see here the next chapter number 1, the rotational dynamics, and the next point is the centripetal force and centrifugal force. You have to ask these questions always. What is the distinguish between the centripetal force and centrifugal force? आतापर्यंत नेहमी आलेला हा क्वेश्चन आहे का? What is the distinguish between centripetal and centrifugal? Then first we have to see here what is meant by the centripetal force. The centripetal force means what? A particle performing UCM acted upon by the force. It is directed along the radius towards the center of the circle. See this arrow towards the center of the circle is called as the centripetal force. Particle performing UCM acted upon by the force directed along the radius towards the center of the circle. Show this arrow towards the center of the circle is called as the centripetal force. Then centripetal force is nothing but what? It is the product of mass and the centripetal acceleration or radial acceleration. Then F is equal to m into v square upon r, or simply F is equal to mv square upon r. This is a very important formula for the centripetal force. F is equal to mv square upon r. If you have to substitute this relation, v is equal to r omega, then v square r square omega square, one r should be cancelled, and second one formula is centripetal force F is equal to mr omega square. Okay, substituting the v is equal to r omega, next form of the centripetal force is nothing but F is equal to m into r into omega square. Okay, you have to see here m is the mass, r is the radius, then v is the this velocity. Then if you have to give the linear velocity, you should use the form F is equal to mv square upon r. If you have to give the angular velocity, then you can use the form F is equal to mr omega square. Then what is meant by the centrifugal force? In centrifugal force, only main distinguish between them is you should see here this arrow is directed towards the center of the circle, and here the away from the center of the circle. That means the particles performing UCM acted upon by the force directed along the radius but away from the center of the circle is called as a centrifugal force. See this arrow which is away from the center of the circle, which is called as the centrifugal force. Then the magnitude of this both centripetal and centrifugal is same, but only a direction is opposite. This is directed towards centripetal, and in centrifugal away from the center of the circle. Then this formula is same, that F is equal to mv square upon r. You can write simply in magnitude form. If we have to plus, then in vector form this is minus, but in magnitude form F is equal to mv square upon r, or F is equal to mr omega square. Only direction is opposite in centripetal and centrifugal. Okay, then centripetal force, for example, centripetal force, the circular motion of moon around the earth due to the gravitational force of attraction, which is acts as a centripetal force. Or second one, the electron revolves in a circular orbit in atom, then this is due to the electrostatic force of attraction between the positively charged nucleus and negatively charged electron. And one another example is that the whirling of the stone. This is the example of the centripetal force. That means a stone is tied at the end of this string, and this revolved the horizontal circle as the tension in this string provided by the necessary this centripetal force. This is nothing but the centripetal force. Then again, the centrifugal force, example of the centrifugal force is nothing but when the car moves along the curved path and the passenger sit in this experiences the push in outward direction due to the centrifugal force. In merry-go-round, the person sit on the chair also push outwards due to the centrifugal force. And another one is example is that in this centrifugal force, that example, the bucket the full of water is rotated in the vertical circle at a particular speed, then so that this water does not fall, and this is because of the the weight of the water is balanced by this centrifugal force acting on it. This is about the centrifugal force. Then second distinguish that in centripetal force is a real force. This force is a real force, and this force is not real. This force is not real, so that it is called as a pseudo force. This is called as a pseudo force. We have to also see why this centrifugal force is called as the pseudo force. Because sometimes it's happened the frame of reference, which means with an acceleration relative to the fixed frame, is called as a non-inertial or accelerated frame of reference. Then the Newton's law of motion in this centrifugal force is not applicable, and this Newton's law make the applicable in such accelerated frame. It is necessary assume the existence of one or more fictitious forces act on this object, and such forces are not real. They are arise on account of an acceleration of the frame of reference, and so that these forces are known as the pseudo force. The magnitude of this centrifugal force is same as that of this mv square upon r, or F is equal to mr omega square. This is the another distinguish. The centripetal force is a real and centrifugal force is a not real, which is called as a pseudo force. Okay, this is the second one. And third one, this distinguish between the centripetal and centrifugal. This centripetal force exists the inertial frame of the reference. This force exists the inertial frame of the reference. Inertial frame of the reference. And in this centrifugal force, non-inertial frame of reference will be the exist. Okay, understand this? In this centripetal force, inertial frame of reference will be the exists, and here non-inertial frame of reference will be exist, non-inertial, and here inertial. Okay, non-inertial frame in this centrifugal force and centripetal force, the inertial frame of reference will be the exist. Another distinguish between them. This centripetal force is responsible for the UCM. Responsible for UCM. We know that this uniform circular motion. And this centrifugal force, it maintain the UCM. Centripetal force responsible for UCM. 1 minute. Okay, this responsible for the UCM, and this centrifugal force maintain the UCM. Another one is that this Newton's law of motion is applicable. Newton's law of motion is applicable, and here Newton's law of motion is not applicable. Okay, understand this? These are the four distinguish between the centripetal and centrifugal. One distinguishing is a half marks. Therefore, you can got this 2 marks for the distinguish between the centripetal and centrifugal. Again, see here. The first we have to see here the centripetal means what? The directed towards the center of the circle. Centrifugal means what? Away from the center of the circle. Okay. Here again, see here the center of the directed towards the center of the circle, directed away from the center of the circle. This centripetal force is a real, and this centrifugal force is not real, because Newton's law of motion is not applicable, and we can assume the existence of one or more fictitious forces which can be arise on account of this accelerated motion, so that it is called as the pseudo force. Then in this centripetal force, the inertial frame of reference will be the exist. Here non-inertial frame of reference will be the exist. Then this centripetal force is responsible for UCM, and this centrifugal force is maintain the UCM. This is responsible for UCM and this maintain the UCM. And last one, this Newton's law of motion is applicable in centripetal force, and Newton's law of motion is not applicable in this centrifugal force. Okay, this is the main distinguish between the centripetal and centrifugal. Now you can write this example also. Then you can write also formula mv square upon r. This is also mv square upon r. If you have it in vector form, this is the plus, then this is the minus. So this is the very important distinguish between the centripetal and centrifugal. Now next point we have to also see the banking of rods. Okay, what is meant by the angle of banking? Okay, we have to stop here.